Okay, today we are learning about intermolecular force. This is mainly what we're going to concentrate on the last day this week in class. There are various types of intermolecular forces. Bonds, what it is bonds between atoms inside a molecule. How do they come together? There has to be some force. There's four main types of forces we deal with. There's three types of bonds: ionic, covalent, metallic. In forming these bonds, atoms will obtain noble gas configurations, a lower energy state. We always want to be at low energy states, and greater stability. Intermolecular forces, bonds between molecules. We have hydrogen bonding. We have dipole-dipole forces. We have London dispersion forces. So, intermolecular forces bond between molecules. That's how we have bonding between molecules. These hold the solid and liquid states together. You ever wonder why we have solids or liquids? It's because of these forces. As the name implies, intermolecular forces exist between molecules. Bonds interact. Intermolecular forces exist within molecules. Intramolecular, within molecules. The forces that holds them together. Intermolecular and intramolecular forces. When chemical bonds break, it creates a chemical reaction. That's what the whole next unit is going to be on. An intramolecular force breaks. We have to have energy. We have to have some form of energy to break that bond. One molecule breaks into two molecules. That's a chemical reaction. When intermolecular forces break, it's not a chemical reaction. Example, melting, boiling. So we are not dealing with intramolecular forces, we are dealing with intermolecular forces. Think of changing one state to another state. The molecule stays the same, it just is a different form. Too closely together becomes too far apart. These are weak. These forces are not strong, like an ionic bond. These are very weak forces. Remember that. And go on and write these. Intermolecular forces are weak. Write that down to turn in. First off, we have hydrogen bonding. These occur between a polar covalent molecules that possess a hydrogen bonded to an extremely electronegative element. Specifically, N, O, and F. Where these are the most electronegative. They're going to have polarity. Think of water. Water is H2O. It is very polar. So you have the hydrogen bonding because of the polarity. It's why H2O forms crystal-like structures. Don't you guys just love chemistry? Dipole-dipole forces. Only polar covalent molecules have the ability to form dipole-dipole attractions between molecules. You must have polarity. If you don't have polarity, if it's non-polar, we don't have these forces because we don't have any of the ability to form these forces. They require way too much energy for these forces. This is what the force looks like. This is weaker than the hydrogen bond force. Hydrogen bonding is stronger than dipole-dipole. And dipole-dipole is stronger than London dispersion force, which these are the only types of forces that non-polar covalent molecules can form. They can't form any others. They result from the movement of the electrons in the molecule, which generates the movement of the electrons create a temporary positive and a temporary negative region of the molecule. Because remember how it's not in one place, it jumps around? Well, one side's going to be more positive than the other. This is what this force takes advantage of. Two of the intermolecular forces are associated with polar molecules, hydrogen bonding, dipole-dipole forces. The only one that is associated with nonpolar molecules, London dispersion force. How do you tell which electron holds molecules together? First, look to see if it is a polar or nonpolar. If it's a polar, you have two options. If it's nonpolar, you only have one option. Nonpolar, London dispersion. Polar, either dipole-dipole or hydrogen. Hydrogen is where, when you have an H involved with N, O, or F, most likely it will always be those three because of electronegativity. Hydrogen bonds with N, O, and F because of electronegativity. Write that down. This is your first one for this PowerPoint. Otherwise, it's dipole-dipole. So if it doesn't have a hydrogen, it cannot be hydrogen bonding. Makes sense, right? What type of intermolecular force do the following molecules have? CO2. Is it polar or nonpolar? Well, the two oxygen will be on the side, so it's going to be nonpolar. So what is the only one that we have? London dispersion force. NH3. Do we have a nitrogen with a hydrogen? Yes. So what do you think it is? It's going to be hydrogen bonding. CH3Cl. Do we have an H with a Cl? Yes. So what type of force do you think it's going to be? Hydrogen bonding. HF. What type of bonding do you think that's going to have? That's going to be hydrogen bonding. Write types of intermolecular forces. Write these in your notebook. I want questions and answers written. What is the strongest intermolecular force present for each of the following compounds? Water. Carbon tetrachloride, ammonia, carbon dioxide, phosphorus trichloride, nitrogen, ethane, acetone, methanol, and bromine. Write these down and turn these in. I will actually check for accuracy with these 10. So make sure to go through the Lewis dot, check the polarity. If they're polar and has a hydrogen in one of those three main electronegative atoms, it's going to be hydrogen bonding. If it's nonpolar, you know what type of force it's going to be. All intermolecular bonds are stronger than all intramolecular bonds. Covalent ionic is going to be stronger than intermolecular bonds. Intramolecular bonds are these types, the three main we got. And like I told you as we were going through, for the intermolecular force, hydrogen bond is the strongest. Dipole-dipole force is the medium of the three. Intermolecular force and London dispersion forces is the last one, is the weakest. Of course, the weakest requires more or less energy. Less energy. And of course, the covalent bond requires the most. Actually, this slide isn't right. Ionic is the most, I'm sorry. What intra or intermolecular forces be responsible for the following? Ice melting, holding the atoms of hydrogen and oxygen together. Make sure to write the answers to these down. And you can turn this in. This will be the last one I'll have you write down. Of course, ice melting is what type of, is it intra or inter? Ice melting is a state of matter, so it's going to be one of the intermolecular. Is water, H2O, polar or nonpolar? It's polar, so which one is it going to be? It is going to be hydrogen bonding. That's the thought process you need to go through for these. Thank you for your time.